Hello, everyone. I'm Michał Dżaman. I will try to share some of my personal experiences about deploying Django on a larger scale. So, to begin with, I'm, like I said, I'm Michał. I'm one of the tech leads and senior backend developers and founders at Order Group. We're a small, medium, Python-oriented software agency in Warsaw. Basically, I was in love in Python when I first saw it because it's amazing, and that's why we're all here. I initially developed software that had nothing to do with the web, and I never wanted to do that at that time, because my first hit with Python was software made for the military and the airports. We're developing communication protocols for radars and all that stuff. And that's when I first learned that Python is not the slow, clunky language everybody thinks it is, at least the people that hate on it. And this brings us to the presentation today, because after we have started our own software house, we actually started Django, and then I thought that web is not that bad as it seems. It's actually pretty amazing. And among all the other things I do at work, I'm also responsible for the deployment process of most of our projects. And I will try to bring it forward with the case we had with one of our own projects, but more on that later. Well, who would have thought we're hiring? If you're stoked about Python, Django, or front-end, Xamarin, and all the other things, drop us a line. We'll be in touch. So, broadly, I hope this presentation is for you if you are working on any Django project, because even if it is small at that time and it has several users and it doesn't have to be extremely fast, it works, it's all good, it's tested, it's amazing, you never know when you might actually have to handle a lot of traffic, which is actually good if you do, because personally I don't think there's anything better than developing a project which is actively used. Because if we do something they put in the shelf and never use, it's actually kind of sad. Also, well, let's make a quick poll. How many people actually use actively Django day to day? All right. How many people are new to Django, which is the new point, or they haven't used it at all? All right. I'll try to make it up to you so that you're not in the blue. Also, how many people have deployed Django on a big scale, say, have deployed projects that can handle maybe 1,000 concurrent users without any issues? All right. Well, then hopefully I'll help you all bring it a little bit closer, and it's not as bad as it seems. Also, I'll try not to go into the deployment process and the server-side configuration and tweaking the IOCTL stuff, because hopefully you have sysadmins doing that. But I'll try to present it in the perspective of the developer. So what can you do to make life easier for other people when they're deploying that, and how to bring yourself praise when your app is fast and developing the requests at huge amounts and very short time. So I hope everyone finds something in it for them, and let's get back to the nitty-gritty. So, first of all, a lot of people here use Django. I'm not going to start a framework war on how is it the best, or let's say it's an amazing framework in Python. It's in Python, that's the first good thing. And we'll not focus on the amazing things it has, but the one thing I have heard throughout my work life a lot is it's too big and it's too slow and it's clunky and it's terrible. So if you have a small project or a big project that has to be fast, there's better ways to go. Of course, on really small projects, it has a lot of bloatware because it is the battery included approach. But there was one talk, I think, at PyVav, where one person made a micro framework out of Django. So actually, if you tweak it right, it can really fit your needs, even on small projects. But that's not the point today. One other thing, which actually also helps with the issue that we're discussing today, is that it's code really makes a great read. If you're new to it, or if you're new to Python, or if you want to get a grip of something new, reading the Django code is something I highly recommend. It is changing version to version, so it might not be current if you're reading Django 2.0 code now. I remember my first hit was when I was digging down the query set code in 1.6, and then they changed everything in 1.7. That was really sad, but they actually made it better. All right. As an example, there's a lot of projects, big ones, that we actually use on a day-to-day basis that use Django as the backend. One of the biggest ones that I found that have actually used it actively, all those mentioned. Of course, not all their services are on Django, but, well, I think the main backend of Spotify is in Django. They also use Python for their machine learning stuff. Discus is one of the huge projects. Everyone knows it as the comment section on so many pages. It actually has a lot of documentation, and they write about how they scaled for, I think, tens of millions of requests, and they're also pretty open about how they did it. And this proves that Django can be fast. Django can be deployed at huge scale, so, well, there's nothing stopping us from doing that on our own. And how we actually happened to how we actually had to scale up. We have our own project, which is basically a ticket sales platform. It has been around for 5 years. We deployed it 2 years ago. There was a lot of code that was fine. There was some that needed optimizing. After we deployed it, there was moderate traffic. Everything was working fine. And initially, it was deployed on a single, rather strong, dedicated server. Unfortunately, at that time, it also uses Django channels because it has a WebSocket service for handling an interactive map where you can choose the seats on the venue. And, well, that proved to be a problem, but we'll get back to that at the end. And everything was perfectly fine up until that one day when we were selling tickets for an event that, unfortunately, got mentioned on Twitch. And the thing with Twitch is that it's not really good clients on your website, but there's a lot of them. So when we got that traffic, our servers went WAT. Also, if you don't know what WAT means, I think Michał also mentioned Gary Bernhardt. It's from his Destroy All Software talk. It's amazing. I highly recommend the web presentation. So, well, the servers actually didn't drop any data, but they just stopped responding, so everybody was kind of angry with us. And I think we had a couple days just to improve everything. And let's go through what we did. Of course, this is a very broad subject. There's so many ways to go. There's many things to do. I will try to share some of my experience and what we did, what helped, what proved to be great, what proved to be not so good, what wasted our time, and what proved us to give more headaches than actually help. And, well, of course, there might be better ways to do some things, but I'm open to the discussion afterwards, because every day is a school day. All right. First thing in every project we have ever optimized is the database queries. Of course, it's the biggest thing, usually clunking making your responses slow, especially when people that write the code are not aware of some of the amazing things the Django ORM has. And well, let's go through some of the things that usually help in responding. First of all, the worst thing that we have ever encountered is heavy logic and templates. There is an approach in the model view template or the adaptation of MVC in Django to keep the views as thin as possible, because the templates are essentially views in Django, and to move all the logic possibly to the model sense to stick that out. Why? Because as we will go over later, it's really hard to find those terrible duplicated queries which are used because someone abused template tags and did heavy logics and templates. And whatever IDE we use or how we go through code, templates are not the thing we want to look at when we're actually optimizing. Also, it's a rather small thing, and this is a bunch of code from the Django documentation. Django really nicely optimizes and caches the query sets by default. I'm not sure if this is rather readable, but the thing is, if we organize our code so that we are actually reusing the variable that stores the query set, it will usually not query the database back to back. And the worst thing that we can do is, of course, the exists thing on query sets is amazing, unless we actually want to evaluate the query set afterwards, because the first 2 lines of code we have will actually hit the database once. And if we want to check the query set and we don't care what's inside, that's amazing, because this is a very short query with a limit 1, or it exists. It directly responds with a Boolean from the database. That's great. But then we actually evaluate the query set, which doesn't have to be done. And the next 2 lines are how it is slightly smaller. It is not a big improvement, but if we have a lot of these examples in our code, it can actually prove to be painful afterwards. Also, what else? The Django ORM is amazing, as we all know, but there is something that not all people are aware of, or not people actually go with. Every inheritance of a non-abstract class causes the database to have more tables per each model, and everything, when evaluated, is built through, I guess, left outer joins. So whenever we are using a model and then going through its related objects and then going through those related objects, we are, first of all, generating huge huge queries made of terrible joins, which you can actually print. That's an amazing thing if you're not fully sure if your query is nice on the SQL side, which you don't have to do, but if we want to scale, we actually should do it. And well, one thing that helps, it's not clear at first, but prefetch related and select related can be an amazing thing, because you can just hit the database once and tell the ORM that you will use its related objects, and this will basically put it into one huge query, and you will not have to ask the database over and over again. Also, if you just need a bunch of values, so if you just need 1 or 2 values, if you want a list of objects, evaluating the full query set and using it is a little bit costly, because Django just creates all the objects. It pulls every single field you have in the model, and using values lists also makes the queries much faster and smaller. What else? If we can move the logic to just counts, aggregates, annotations to the database, it also helps, because we don't have to pull the data and then process it and put it back to the logic. This is a rather good improvement. Also, that's something we came across rather late. Well, it is amazing to use the update method for big query sets, because it generates one transaction. It's great. But in terms of creating, if you have a lot of objects to create, the great thing, and it's rather hidden in the documentation, is the bulk create, where you just create a list of constructed fake objects, and then it just creates them all in one transaction. That speeds things up slightly. Also, one thing that happens sometimes, full text queries, whenever you can and whenever it makes sense, switching to Django, Zapier, and Elasticsearch, or any search index backend also helps. What else? Well, I'll try to go through some useful tools we can come across when fixing these issues. One of them that actually helps with a lot is the Django debug toolbar. How many people have actually used this? It's quite a lot. It's one of the best ones. It has a rather clear view of the queries your view has made. It is rather good at locating where your code actually caused the query to happen, as long as it is not in the template, because then it can show some stupid line of code like the render function inside Django, and then you have to dig in and find what actually caused it. Also, one small caveat, it is really slow. If you have somewhere between 800 or 900 calls to SQL, it will make your app really slow, but it's just for debugging, so take some patience and it should be fine. Some other useful tools we have used in the process. Django debug queries proved to be better with more granular control, because you can just wrap specific views and functions and then debug everything that's happening and calling the database. Django extensions, which is something that if you don't use Django extensions, I highly recommend you do. It has quite a lot of nice features making life easier. And one of them is the shell plus command, which is a wrapper over the shell command. So if you want to manipulate queries yourself in the code and in the console, the print SQL flag also prints all the calls that are sent to the database. And there's some other packages like the Django query count. It's also a simple middleware. Or you can, if you prefer, you can define a simple logger for the logging in settings. For Django DB backends, it will just output all the queries itself. Right. I'll go through the obvious again. Of course, if you want to profile the code, you want to make sure that all the lengthy calls are optimized and that they're actually fast to fix and eliminate all the slow code. And then there's Captain Obvious, but well, it actually isn't as easy as it seems, because profiling Django proves to be a challenge at first, because there's a lot of internal Django functions that actually are displayed in the profiling results. And to find what is actually happening and slowing down your application and being the bottleneck is a bit of an issue. Well, the simple things we can do at first is, first of all, move all the heavy processing to asynchronous tasks. Celery seems to be the most common option here. And well, this, of course, has to be done not during the request calls, because if you delay the task and make the user wait for the response, they will be pretty angry about the response time. But if you have specific tasks that are, say, done periodically every hour, or if if you can calculate something on your object on save, this is actually rather troublesome, because you have to be really careful with extending save. Some cases I've seen, people do not see how many times the method is actually invoked. So if you have a lot of inheritance and you check things, then call save again, well, sometimes I've seen it called 5 or 6 times before actually returning what it had to do. Also, one good thing to do is, like I said, Django is possible to slim down. And the first thing that can slow it down is the middleware. If, by any chance, someone has put some heavy code in the middleware, it usually will be called every single request. And for development, this is also annoying, because if you have static files served through Django, it will be even 10 times slower. So yes, this is one thing that I would highly recommend, and it helped in many cases. Also, we'll get back to that in a second, because this is a big section. Use cache wherever you can. This speeds up everything real well, but this is the next step. Also, as Django suggests, keep everything dry, because if you optimize it in one place, you don't want to have to worry if the code is actually multiplied in multiple places. So if you fix the source, it will be much more effective if you keep your code clean. Also, as I mentioned, render calls are actually painful to profile, because, well, this is heavy Django logic, and there's a lot of inclusions, and the way this works can be rather hard to pinpoint the source of your problems. Some useful tools for profiling. One of the cleanest and easiest to use at first is Django Silk, from our experience. It has a rather nice web interface. It actually, if you define it with a simple context manager or a decorator on the functions or views you want to watch, and it saves all the responses, all the queries and everything in the database, and then you can just browse and see what is happening on there. Also, a simple wrapper over C profile, which, well, all the profilers take some getting used to. If you don't have to use them, then it is sometimes good. But Django profile middleware is a very simple wrapper over the C profiler, analyzing the code behind. Also, it's one thing we usually use, and it's also highly recommended. JetBrains PyCharm IDE, debugger, and profiler has this wrapped in the IDE itself. So if you're already using it, it is also great. And the worst case, which usually happens, if you want to profile your application on the deployment server because everything is fine for you, but it doesn't really work on production, then you usually have to go with external APMs. One we used was from Datadog. It was fine for pinpointing the issue, but it's a commercial tool, so well, there should be better ways to do that. As I have mentioned, cache is great, and we have to use it extensively, but it also proves to cause some headaches. First of all, Django has a built-in cache framework, and it supports all the biggest backends. It's usually suggesting memcached. It can also store things in the database, which I don't think is the best idea usually, because database is usually the heaviest thing in our application, and putting cache there usually is not the best solution. It can also store the cache in the file system or local memory. And it has some utilities for caching the whole page if you want through middleware, if it's really static. Per view caches via view decorators, which also bear in mind, of course, the parameters and everything you pass to the URL, but they're not too granular, which doesn't make them too useful often. And you can cache the whole fragments in templates, which is actually sometimes very a nice feature to use. Or you can manually manage the cache yourself in Python code. However, from my personal experience, there are better ways to go around it and more efficient solutions. And the main one we personally use is Django Cache Ops. I will get back to its main features in a second, but the thing is, and this is also one of the problems with caching, it has really good dynamic invalidation. So the problems with the cache, as mentioned, is that if your Django application serves content that is static, doesn't change ever, it will serve. If the cache is used extensively, it will work extremely fast because every request to Django will basically pull the content from the cache, put it back, and even the worst cache will actually work really fast there. Problems begin when your content or your response or whatever you're exporting out of Django is dynamic and it has sessions, CSRS, session-based content for each user, because if you go out of the box, if you just wrap a view and it's not properly configured, you will take the first request, cache the content, and put it out to everyone around with the data for the first user. It's actually not too good, and it's not secure, so we should never do that. And well, this is where the other solutions also help. But the thing is, we do not want to manage the cache expiry time manually, and this is where the dynamic invalidation helps. The best thing about Django Cache Ops, which, as a matter of fact, it uses Redis instead of memcached, and somehow in our tests it proved to be the fastest. The great thing it has is that when you are caching an object, you can input the query set or any other set of parameters you have into the cache definition, and if any object in that table changes, unfortunately we cannot watch objects themselves, but if anyone changes anything in that table, all the cache will automatically be invalidated, which is great because you don't have to worry about it manually. It is fast, and of course, the other worst thing you could do is to invalidate all your cache when something changes, because this will not cause it to be used efficiently. Also, it has most of the good mechanisms that the main Django framework has. It has template tags for caching template fragments. It has a dogpile prevention mechanism, which also can be an issue. This thing, just in short, is if your cache is invalidated, and say 1,000 people ask for the same thing, but it's not in the cache, Django cache ops will actually log the first request, build the cache value, store it, and then respond to everyone with the cached value instead of evaluating it 1,000 times until the cache is actually stored inside the cache storage. Unfortunately, from our experience, it's not greatly documented, but you can, of course, get how it works, and it's not too complicated. And one thing that is strange, maybe we didn't search well, but it's impossible to disable the cache for development manually because you have to input its methods in query sets inside your views. And from what we read in the documentation, it's deprecated because it's not used. The only downside of that is that you have to have Redis on when you're developing your code. Some other packages which feature similar mechanisms, we haven't used them because Django cache ops proves to be better. There's actually, these are the big ones, there's a lot of them, but I highly recommend checking them instead of going with the built-in Django option. Also, it's not entirely on the Python side, but on some websites, it's actually great to use an external cache. Either if it is varnish, which is in between your load balancer and your Django workers, and it doesn't even hit Django if it knows that this request was cached, or you can manipulate the cache control headers so that the user's browser actually knows that they have the content that you want to see, and the request will never even hit your website if they have it stored. One little thing that can be helpful. Every time, by default, if you are rendering templates in Django, for some reason it parses all the templates every time, and a simple switch to changing the class of the template loader to cached loader will cause it to store it in cache and then reuse it afterwards. It, of course, is terrible for development because you have to restart the application to see any changes, but it helps in production. One thing you probably have done by now if you're optimizing your application is load testing. We will not reinvent the wheel here, but from I will just share some of the tools that we have used on our side. First of all, Locust proves to be really good because, first of all, you can write your scenarios in Python, and it has a very simple UI. And a great thing, it can be scalable. So you can define your own cluster, run it on multiple machines. And you do want to do that because if you're testing your application for, say, 10,000 concurrent requests, you will possibly block your machine on the performance of Locust itself instead of your application. Also, we have used JMeter for some of testing on our side, but this is also a great tool. I recommend this one. If you are on that same decision we had to make, I recommend you check it out. If it doesn't work for you, there's a bunch of other ones. One thing to make sure when you're testing, in general, of course, be thorough and do not just check your main page for a million same requests. It takes some time, but it's amazing to develop your load tests so that they actually test the flow the user will do on the website, because what if your main page is extremely fast, but if they actually add something to the cart and go on, it blocks them and they just see a huge loader and they get a 503, they will not be happy. So it's good to do this early so that you get more results faster. Also, it's if you're developing something that has large data sets in the database or processes a lot of stuff, it's really good to load test on practical data, as if you can test on the same hardware as the production development, it's also most accurate in effect. Right. Also, in our case, when we were testing for above 10,000 concurrent users, the self-hosted tools somehow got stuck, as it seems, on bandwidth. This is something you don't necessarily think at first because you're testing the CPU output and the CPU load on your side. But in our case, when we did the math, it turned out that the requests took longer because the communication between the application and the load tester itself, which was in the same network, got stuck in 1 gigabit. So this is something to bear in mind. And it also helps to go with external tools that will swarm your application from the outside. And there's also a plethora of those. And some we have used and some I would recommend is, first of all, loader.io. Because, first of all, they're all commercial for a reason. But their free plan is useful. And they are rather good for creating your test plans in their web UI, and they prove to work. There are a lot of different ones, and the main feature of Loader.io is that I think they have a support for 100,000 users, which is quite a lot compared to the other ones, such as Load Impact, which is much more expensive, but and they have a better UI. But their highest plan, which is like 5 times the price, allows up to 5,000 users, which was not the case in our situation. Also, as I have mentioned, our application was using WebSockets, and there is a different issue when you actually start load testing your application. You usually have to dig deeper into the kernel configuration because you will run across strange things like running out of open file descriptors, open sockets, database connection pools, which is also rather annoying when you swarm it and you see like your database was configured to support 1,000 concurrent connections. And if we switch to asynchronous workers, which we'll go to, can actually happen pretty easily. And there are some of those other things you will have to fix on the system side, which is, we'll not get into that too much because we're talking about Django today. Then, some good things and good practices to do with your deployment. First of all, the two most common and reliable solutions for deploying the most common WSGI solutions. Gunicorn is one of them, and one we actually went with. Gunicorn and USGI are said to be the best. They switch back and forth on which one is actually better. And a lot of discussion actually relies on which one is Mozilla using right now. And they first said that Gunicorn is better because of the low CPU usage and efficient memory consumption. But then they switched to USGI because it's I don't remember the reason, but they said that it's better and more lightweight for them in terms of configuration. Both are actually great, but something you should definitely consider is when going with either of those, switching the worker classes. By default, Gunicorn uses threads, and if your application is heavy on the I/O, it helps to switch to G-event workers, which are fully asynchronous. It is much faster, and you see huge improvements in your load tests. However, the first thing we got stuck on in this case is the database connection pool. Because if, say, you have 20 workers, by default, you will just need 20 open connections on the database side. But if you queue up, say there's 1,000 users incoming, they will all generate an asynchronous task, which will open its own connection to the database. It is more complicated to configure that on that side. And also, threads are also set to be better on CPU-heavy tasks in Django. Also, this should never really be a bottleneck. We went through checking if Gunicorn was actually the problem on our side. And if it is properly configured, and if you find your working count, the general rule of thumb is 2 times your cores plus 1 for switching. And all the keep alives and timeouts, which is also more of a server-side thing, they should never be your issue. Also, if we want to scale, and we have to prepare for that, it's good to use a proxy server. It is not that hard. Usually Nginx, which is often used as the reverse proxy for Django for Unicorn itself. An amazing thing it also has a load balancer. But yeah, so it serves two features, and on our side, this is the go-to solution we would recommend. And it's just really important to configure the timeouts, the keep alive connections, and everything on that side, so that doesn't stop your app from running well. Also, the worst thing we actually came across, and I hope you never actually hit it, but there's some good practices to prepare your project for scaling. Because the thing is that Django does not scale much. It's your application that has to scale. And the first thing we have to do is to make your application independent of the server. So if it doesn't care if it runs on one server, 5 or 10, then you can basically scale it however you like. And this is really usually the issue when you want to scale your application, that someone stores files, so the database is not ready for that. And this is the first thing. Usually, you can put the database on an external server. There's no problems with that, up until the point when you have critical sections that actually utilize the database transactions so that they want to be exclusive. It's better not to learn it the hard way. Some people think that if they wrap their method in transaction atomic, that everything inside is atomic. It will never overlap with other operations. Unfortunately, not. With the default transaction separation settings for Postgres, for instance, you have to use select for update, and you really have to do that carefully, because if you utilize that with select related, you can actually generate double locks, which will block your application. This is more of a code optimizing thing, but make sure you think of it, even if you're not scaling, if you're developing for a single server deployment, it's good to think of it ahead. Also, one issue which usually occurs is the static and media files and uploads. If your application utilizes heavy uploaded files and everything, it usually is the main thing that will pin it to the server it is on. Of course, you can use shared storage, and if you do that, that's great. The main solution that helped us usually was switching to an external S3 storage. We tried to go away from Amazon for as long as we can, because we just prefer the dedicated solution. But actually, S3 is really nicely wrapped with Django storages. You do not have to think about it much, other than the problem when you actually have to use the files in your application, because the way it works, it just the media roles point to S3. But if you want to open the file and say wrap it in a PDF, you have to manually synchronize them to the server and then process them and put them back. This is the main issue. Also, collect static starts working terribly slow if you start to use it, because it compares all the file content with the external storage. There is a little package called collect fast, which helps the problem slightly. The other thing, and the last one in here, is logging. I'd say you switch to an external logging solution as fast as you can, because, well, it usually has built-in error reporting. It has a nicer interface than just browsing for the files. And from our experience, when we were searching for the best solution, there's really not too much to go other than the ELK stack, which is the combination of Elasticsearch, Logstash, and Kibana. And if you utilize that well, you can also just put the logs on an external server, and depending on you have one server on 15, you will have all the errors and everything in one place. That's really convenient at some point. If you have done all that, then the last step is scaling up if you actually need to, because if you have optimized most of your slow code in your application, sometimes it happens that you can actually process millions of requests without scaling vertically or horizontally. But if you have to, there are some suggested solutions at first. First thing you want to get out of the main server with your workers, it's just to put the database to a different machine, because as I have mentioned before, especially in the cases of our projects, the database was the main thing slowing everything down. As I have mentioned before, it's good to put the media and static files externally, even better if it's a CDN, because it will speed up the delivery to the client. If needed, it's also good to externalize your Celery, Redis, or Memcached, or whatever external services you use to put them out. And also, if it is needed, if they are the bottleneck, to replicate them and create multiple instances of them. If you have done that and it still needs to be done, make sure you utilize the resources on all the servers you have. And if needed, at this point, it is really a simple task to just multiply and have a lot of them. This, we have covered that. Some other problems, just to summarize. Unfortunately, you will always have to search for the next bottleneck, because for load testing and preparing for all that has to come with a lot of traffic, you're basically DDoSing yourself. But one good thing we have actually found out through the process, is good to use an external DDoS security middleware as CloudFront in Amazon, or Cloudflare for your servers, because if you're deploying multiple servers, it's really nice to hide the IPs and the identification of your servers behind some sort of software, just like they do, because it makes it harder to pinpoint one of your servers. Also, of course, minify the output of your application. Or in our case, it turned out that the application was super fast, but the amount of HTML it actually put out, which was somewhere between 0.5 megabyte to 1 megabyte, proved to be the problem. Make sure this is also small. And as I am running out of time, one thing, if you actually come across Django channels, and if you use it, the thing it does, it has its own WSGI. It's called Daphne. It is different in version 2.0 now, but when we use 1.1, the problem is it actually takes all the requests, puts it into a Redis storage, and then the workers pull it out and process them. And this is awful for processing the HTML responses and everything else other than WebSockets. The good solution to do in this case is to manually reroute all the HTTP requests to gUnicorn on the level of your reverse proxy, and to make Daphne and Django channels just serve for the WebSocket. It really helps. All right, so that is all I had for today. I'm not sure we have time for questions, but hopefully anyone has some.
Okay, why don't you move HTML templates to the front end and use JavaScript, and do not transfer it every time?
Well, if it is possible, then it's great. Of course, that's the way to go.
So that's the question.
Yes, that's that. In the case we had, it was a very big project that we had to scale quickly. So it would mean just rebuilding it from scratch. Of course, it's usually a great thing to do at some point. But sometimes, if the projects utilize Django templates to a heavy basis, it's really hard to do. But it is a good project decision in the first place.
Okay, thank you.
Anyone else?
I have a question. You mentioned that you use gUnicorn
Yes.
on your site, and have you ever tried to use also the? My question was about the gUnicorn, because you mentioned that you use it. So have you ever tried to compare the performance with the Björn, for example?
I read about Björn, and in some tests it has like crazy results, but we haven't tested it yet, because in some benchmarks it proved to be 10 times faster. But on the other hand, if you actually read through gUnicorn code, there is not much happening there to make it slow. So, well, it didn't slow us down, so we didn't switch forward to anything else. But I've heard in results that Björn is also great. Right.
I saw you recommend bulk create.
Yes.
And I wanted to ask, what do you think about using signals in Django?
They are good, but they can also be a trouble to debug if they are actually the source of your trouble, because it's well, if they're used wisely, they're great. But if someone makes a mistake in signals, it's really hard to find usually.
Yeah, and you also can't use them with query set update or bar create.
Yes.
Right.
Well, we usually went with overriding safe, but yes, that's all right. Anyone else? Great. Thank you, Dan, for listening. Hope you